Hello. Let's start with a fun fact. In 1893, there was a US Constitution Amendment proposal to change the name of the country to United States of Earth. So next time someone complains to you about how American teams, when they win their league, they call themselves world champions, you remind them that it could have been much, much worse. And the relevancy of this will reveal itself at the end, so stay tuned. My name is Hakan, and software engineer at Lyft. We built an alerting system about a couple years ago, and I'll be talking about that. Here's a little peek into the outline. So I want to talk about, being down as a company, your systems. We all try not to be down, right? That's all our job. It's really bad. But is it really bad? For our users. It's bad for the company. We're not making money. Obviously, our jobs are at stake. But, so I selected a few examples here, completely random, not to prove a point at all, that it may not be that bad for the users. So, for example, if Facebook, Instagram is down, well, they can always go, listen to music, or if they're feeling adventurous, they can go outside. If Slack is down, now it's bad for the, customer companies, but the users who are the employees of those companies, they can go get a coffee for 30 minutes if it's down. They can go, load the dishwasher, or if they're feeling adventurous, they can go outside. And all these other things, Netflix, Vesire, C-SPAN Plus. So again, they can read a book maybe, or if they're feeling adventurous, I forgot my actual point actually. Okay. So, but Lyft, on the other hand, when we are down, our users are already outside. They are on an adventure. They are trying to, go to their job interview. They are trying to get to their doctor appointment or to their work. So if we are down, it's not just an inconvenience. It's a major issue. And now think about how frustrated you were when you're stuck in traffic, and think about now you're stuck, not being able to get in traffic. So that's why alerting is very important for Lyft. So I'll talk about alerting mainly, but of course alerting always comes with a metric system. And most of this talk will be about the alerting system itself, but I will also talk about how we also worked on the metric system and how it relates to it. And most of the cost always comes from the metric system. So if you go back to late 2019, Lyft has been growing pretty fast the last couple of years, and we had a vendor that we were using for our metric needs, and there was an alerting system built on top, which was basically given to us for free. And because of all the growth, we were about at 100,000 alerts per minute, and we were emitting about 40 billion data points a second at that moment. And the cost was quite prohibitive at this point. We were getting close to 8 figures per year, especially if you take into account the growth that we were expecting. And of course, we were going to grow, right? Why wouldn't we? We've been growing every year, and it would take like a global catastrophe for us not to keep growing. But with growth, with the cost and scale, there was also reliability issues. We were having issues. Our vendor weren't able to always handle the load. And since we didn't own the thing, it was quite frustrating for us. We didn't really have clear insight into the issues. And we didn't really have clear guidance how things were going to go if we keep growing. So we wanted to move away, but to make it easy, we thought that the best way is to decouple the alerting part from the metric engine, metric data store, and then that would make it easy for migration, and it would also make it easy to do migration if you don't like the first time we migrate. So once we made the decision to separate the alerting system from the metric data store, we started looking into the options for the alerting system part. And we were exploring some third parties. Usually it wasn't that easy because they usually don't give you just the alerting system. It comes with the metric engine. And we didn't want to get stuck by moving the whole thing to another vendor and then have the same issues. We looked into some open source. There were some options, but we didn't like what we saw. And we didn't want to, maintain our own fork if and based on and dependent on updates. So we pretty much were set on building the alerting part of the system in-house because we thought we had a clear idea about the scope, and we really wanted to have full control over the software lifecycle in terms of issues and all that and bug fixes, and basically increase our institutional knowledge about these. But of course, as Corey said, we already had the gut feeling that we wanted to build it, and all this is kind of reasons we came up with, maybe after the fact, right? So I'll let you read this comment from Hacker News I saw a few months ago. So we were definitely at the let's just roll our own, how hard can it be point. And we were hoping that we won't get to the oh crap point. I actually reached out to this person about this code, and they agreed that it's fine to code them here, and they said they still feel the same way. And it's fine. Yeah, fine. All right, let's keep going with the scope and design. So our scope was to build a system that can work with any metric data store, and preferably more than one actually, both because of doing migration and also later on because we might want to integrate with other data stores, and we want to be able to configure our alerts, specifying different alerting medium, frequency, snoozing, again the metric data store, and different conditions for the alerting logic. And our thinking about the migration was that we would start operating it along with our third-party system until we validate everything about it. So we tried to keep it pretty determined in the beginning and not allow much scope creep. Existing system. So existing system is pretty simple, right? We just, well actually this doesn't show the metric side. Obviously we're sending all our metrics to our third-party provider, and then they provide us the alerting system as well. And this part only shows how the integration about the alerting is done. We have a big repo that has the configurations for all the alerts, for all the services that we have. And then whenever something is added and removed, we would be basically calling our third party and update the alerts on their side. And then when there is an alert happening, they would call our own pager service, which is basically a wrap around PagerDuty and some other notification mechanisms. And that would be it. The proposed system we had looks like this. It seems complicated, but it's not actually that much complicated. So if we start with the top, we would have an alerts database, which is basically all the definitions of all the alerts. And then the alert storage service is kind of like a backend service that would be powering a web app, and it would also reveal an API if other services wants to do certain things programmatically. And it would talk to the metric engines to show what the current state of the metric is of the query of the alert. And the bottom part is the actual the alert evaluation and so on. So we would have a scheduler that would read all the alerts from the alerts database, and updates it regularly. And then it would schedule all those alerts based on how frequent they need to be scheduled, and then call the evaluator for evaluation of these alerts. An evaluator would evaluate the alerts by checking with the metric engine and the latest state of the alert from the alert state database. And again, it would call our existing pager service if needed. A little bit more detail about the scheduler. We wrote this, actually the whole project in Go, other than the front end. And this is kind of in Go style how the scheduler would work. Scheduler is only one instance, basically, but we wanted to have a few, obviously, backups. So there would be like a few scheduler instances, but only one would be the main scheduler, and the others would basically try to become a main scheduler, but fail most of the time until the main scheduler dies for any reason. So the main scheduler would get the distributed log and then become the main scheduler. And then it would basically have two main functions, the schedule alerts function and the drain queue function. The schedule alert Go routine would wake up every 1 second and schedule all the alerts for that second, which means put them all into a Go channel of alerts, and then go to sleep and wake up in next second again to do the same thing. And the drain queue Go routine would basically run non-stop, reading from the channel, and then based on the alert definition, call, actually, it has nothing to do with the alert definition, it just calls the evaluator. Evaluator, based on the alert definition, calls the right metric engine, and then based on whatever logic it has, based on the configuration, would evaluate, and depending on the state changes of the alert, it would take some actions. Well, more like trigger the actions that's needed. And this is some of the proposed actions that we had in the beginning. I'm not sure if there have been more granularity on these. So how we built it. The schedule evaluator part, this part was the part that I was mainly involved in. It took me about 4 months to write this part until we get to the MVP part where we can load alerts, schedule them, evaluate them, and so on. And then I rolled off this project, and another engineer came in, and then they worked on it for about 3 more months until we were ready for migration. And alert storage service, there was a bit more work to do there because of the front end and charting and all that. It took about roughly 6 months, about 2 to 3 engineers on and off working on it. And then we did the migration in 2 months to migrate all the alerts to the new system, and we were done. Isn't that great? So, you have 20 minutes back. Let's talk about migration. Yes, the plan was to do it in 2 to 3 months. And then, however, very, very soon into the migration, we ran into issues, and our metric provider basically rate limiting us, didn't want us to query them as much as we wanted. So which meant that we had to actually wait until our metric migration was also underway, and that goes through so that we would do it in conjunction with that, which took about 1.5 years. So what we did was service by service migration. We had some volunteer services, some volunteer teams that would go onto our system as well, in addition to the third party that we were using. So for them, third party and the in-house system would be alerting together at first, which was an interesting experience because we found a lot of the time that our system would be alerting much faster. And it's probably because the third party had a lot of noise reduction mechanisms going on that we didn't have, which was obviously a trade-off. But that helped us in the end because since we own the system, we can actually tune it in a lot more in tune with our needs, and we can talk to our teams how they are using alerting, how they are defining their alerts, so that we can still keep the mean time to detection low while not increasing the noise a lot, since we own the whole thing. So when we were running the things in shadow mode, it wasn't easy because the signal was low by definition in alerts, right? You don't get the alerts. A lot of the systems work normally most of the time. So it's really hard to tell when there is nothing on both sides. How can you tell it's correct, right? And I mean, many alerts never actually fire in their lifetimes. And so we had to do a lot of automated and manual checks, and we need to do a lot of checking how the alerts are used and so on, which was actually good because there was an opportunity for checking alert validity. So looking back, I submitted this talk in the beginning of 2020. So I was thinking that in 6 months, not much have changed. I'm just going to talk about the system. We haven't really done the migration by then. But now, 2 years later, it's great that I can actually talk about the whole thing. In the end, the cost issues, of course, again, this is the metric engine cost mainly. Since we have rolled off the third party and are using our in-house metric data store, we didn't build that. It's an open source project, the metric data store. But the infrastructure cost from almost 8 figures, we went down to about low 7 figures. And right now, I talked to the team and they said that so that data store isn't completely great, right? It also has its own problems. About roughly half to full engineer time is being spent maintaining that data store. But I like to actually say something about this. Like when you're maintaining or working on your own system, that's actually not completely time wasted because that engineer is leveling up themselves. They're learning about it. And they're also building institutional knowledge about how to run this kind of system. Whereas when you're dealing with vendor issues, you're basically talking to them, waiting for their response and all that. So they're building their institutional knowledge. They're making their systems better. But it's not really, your engineers aren't leveling up themselves other than, talking and communicating, I guess, which is a good thing, maybe, I don't know. So let's see, how was it for our customers, meaning the other engineers in the company? They were unhappy during the transition, especially the new UI, because during an incident, all of a sudden, they don't typically look at the alerting system UI unless something is happening. So during a stressful time, they have to look at it and then they're like, oh yeah, this changed. I don't know how to use this. So that was frustrating at first. We also switched to PromQL for our metric definition during this migration. And there was complaints about it in the beginning as well, because now there was another language that the developers need to learn. And there were some misunderstandings on the syntax compared to the other language that we were using. However, I think it was a big win in the end, because now if you want to migrate to another metric data store, then we don't have to do this, since PromQL is pretty accepted by other data stores as well. And the complaints from the developers were pretty much non-existent after a few months. And overall, we are having a better performance on alert querying and faster mean time to detection. So what about the team, the observability team who built this? I think we were pretty happy, to build a whole system from scratch and see it in action. And I'd like to say something about people talk about 10x engineer a lot. Like, could be just some engineers are amazing, or some engineers are enablers of other engineers. And I think in terms of productivity, most engineers have, like a multiple X engineer in themselves. It's just they need the motivation and empowerment to be able to do that. And I think in this case, at least, building gave us that opportunity to, really be motivated and level up ourselves. And we actually didn't know Go, none of us, at the beginning of this project. And we built the whole thing while learning Go as well. And when I go back, we didn't do a bad job, honestly. So that's, I think, what's missing sometimes when people are talking about buy versus build. Because they say, okay, engineering time is valuable, where should it be spent? trying to integrate something or trying to build something. But that time isn't exactly absolutely equal to each other, because 1 hour when the engineer is motivated and focused, that 1 hour will be worth a lot more than 1 hour when they are not really into it, doing something else. And I know this is not something engineering managers or general management doesn't want to hear, but as an engineer, that's how it is. So the new system has been issue-free, which is good for us, for the maintainers. And at this point, for the alerting system side, we are not doing any further development other than regular security updates. There were some feature requests after the migration, which has been completed. So we're not really doing much about it. It's chugging along pretty well. So I think overall, we were able to hit the sweet spot by separating the alerting system and building that for our scale, and not trying to do the same thing for a metric data store. And so I think build was the right choice, looking back 2 years afterwards. But I'll put a disclaimer, of course, saying for now, because when I was preparing for this talk, I saw a talk by a Lyft colleague from 2017 in this conference, and they were describing the logging ingestion pipeline they built, and they were pretty happy with it. It was working great in 2017. However, in 2019, when I joined the company, that was like the biggest pain point of our observability team, that system. Everybody was complaining about it because during that 2 years growth, it got bloated. A lot of new things added into it without good refactoring. And we were basically couldn't wait to get rid of it. So, that's why it seems like we made the right choice, but I don't know how it's going to be from 2 years from now. And if anybody is watching, in 3 years, this talk and thinking, oh my God, this system is not working at all. What is he talking about? Well, I think there's a camera somewhere here. I apologize. And with that, I'm happy to get any questions you have. Okay.
How do you handle alerting or do you have any kind of backup or redundancy?
Can you repeat a little louder?
How do you handle alerting or the in-house tool that you built to deal with alerting?
Yes, that's a great question.
Just repeat it one more time.
Yes, so the question is how do we alert on the alerting system itself? Basically, how do we monitor that? So right now, in the beginning, we thought we would use another third party, or we would use the alerting system itself in a previous version that's deployed in some other infrastructure. But I think right now, it's basically, we have 2 separate clusters for staging and production. And staging is watching the production, and production is watching the staging. And that's been working fine so far. But I think we should probably think about what I just mentioned for better redundancy.
Here's one right here.
Are you still using one large repo for all of your alerting tools, or are you using your UI to let people set new alerts to that?
Yeah, in the beginning, the idea was UI could be used for that, but and there would be like versioning and such in the UI. But I don't think we followed up with that because it was just too much work to deal with it. And the big repo is not only used for alerting, it's also used for dashboards. It also defines all the dashboards for all the services. So that's, I'm not aware if we want to also make an adjustment on that, but right now that's how it is, yeah.
There was one, yeah, it was right here, yeah.
I assume you on the page of the 100K unit for alerts?
I think we reduced some of that number during the migration. I think I mentioned that we looked into all the alerts, or encouraged all the teams to look into their alerts and so on. I think we made some headways in that it's not as much, even though 2 years passed and could have grown. So I'm probably in the same ballpark, but it's less.
Yeah, right here.
I think one of the numbers I saw on one of the slides was 100,000 alerts per second.
Per minute.
Per minute.
100,000 alerts per minute, yeah.
When you think about the database getting, so the external systems that you relied on, like, or the external projects that maybe you don't have control of, was scaling databases a problem, and how did you?
So was scaling databases a problem for that volume of alerts?
Well, not really. I mean, 100,000 records isn't that much in a database usually for right now. So, and this database is only used mainly to load all the alerts and then do some updates by one system. And then the other system is doing some, one-off alerts, obviously based on the usage. But again, we have only hundreds of people using the system in the UI. So it's been fine.
Were there any other questions? Oh, we got one right here.
Thank you. In your build binary slide, you had like third-party services or third-party services and open source. And under both, you had a bullet point about anti-patterns. And I was hoping you could unpack that a little bit and what kind of anti-patterns you have.
So what kind of anti-patterns? Yeah.
Yeah, this was given to you by my boss to mention, and I didn't want to mention because I don't really fully know. But I think his point was mainly that the part about mean time to detection, that third party or open source, they might have some generalistic algorithms to be able to reduce the noise. And he doesn't like that. He thinks that we should limit some of that so that we can tune our alerts instead of trying to rely on things like, oh, if this alert is firing for 5 minutes, then actual fire, and so on. So I think that's one of them.
Yeah, great question. Any other questions? I see, yep, one more back there. Yeah. What metrics data store? Or what volume?
Yeah, I'm not sure about the volume because I'm not in the team anymore, but we are using M3.
And then any other questions up the top? No? One more?
During this project, did you change any part of the data collection or actually getting the data to the metrics data store, or did that remain the same before and after?
Did data collection change?
Yeah, the data collection did not change. We are still using, I think, StatsD from the instances, and we actually still, I think the proxy that collects everything from all the instances is still named after the vendor. So we haven't changed anything.
Any other questions? Yeah, here we go.
Did you implement any kind of governance or life cycles around the alerts to make sure that alerts did the same if they weren't actually needed anymore?
Governance around the alerts?
Not that I'm aware of. I think, I mean, if vendor services are deprecated or something, then we do that. But other than that, I don't think we do anything like that.
I thought I saw one up top. Yep.
Can you comment a little bit about alert fatigue? If you're talking about 100,000 alerts per minute, and just the boss is saying it's all alerts.
Yeah, commenting on alert fatigue.
On the on-call rotation?
Yeah,
I
boss on the on-call
okay,
rotation.
maybe I think I messed this whole thing up, if that's the question. So 100,000 alerts is not actual firing alerts. 100,000 alerts is how many alerts there are that could fire.
Gotcha. All right. Any other questions? I'm sure got everyone here. All right. Let's give another round of applause.
Thank you.